Hello everyone. Yep, that's Joseph Celestine Donald. I know what you're wondering. What exactly is he doing? Well, honestly, that's just him on a very good day, trying to convince his boss he's right and the boss is wrong. Here's a bit of a backstory. Joseph worked on a design where the factor of safety is exactly 2. Now the argument is that enough considering the nature of the component? Well, let's see how it goes. I'll let you know who won at the end of this video. Welcome to the very first video in his new series, Theory to Reality, and yes, his boss is definitely wrong. In this series, we're going to bridge the gap between theoretical simulations, complex calculations, and real-life physical parts. For this first episode, we're tackling the Bevel Gear. Joseph's goal is to show you how a few simple formulas transform into a precise, functioning mechanical component. The Bevel Gear blueprint. The why? Ever wonder how we turn motion around a corner? Meet the Bevel Gear. Today, we're calculating a high-precision pair, a 20-tooth pinion driving a 30-tooth gear. With a module of 2, we're aiming for a compact but beefy 1.5:1 ratio. Step 1. Pitch diameter. First, we need the pitch diameter. This is the invisible circle where the teeth actually do the work. The formula is simple, module multiplied by the tooth count. For our pinion, 2 times 20 gives us 40 millimeters. For the gear, 2 times 30 gives us 60 millimeters. Easy, right? But since these are cones, they lean. Step 2. Pitch angle and cone distance. To get them to mesh at 90 degrees, we calculate the pitch angle. Using a little trigonometry, the arctangent of our tooth ratio, we find the gear leans at 56.31 degrees and the pinion at 33.69 degrees. They fit together like a perfect puzzle piece. The cone distance. The distance to the point where the shafts intersect is roughly 36.06 millimeters. This is the backbone of our gear shape. Step 3. Tooth anatomy. Now for the teeth. The addendum, or the top, is 2 millimeters. The dedendum, or the root, is slightly larger at 2.5 millimeters. Why? To give us a little breathing room so the teeth don't bottom out. We then taper these toward the apex using the addendum angle of about 3.17 degrees. Step 4. The reality check. Finally, the most important number for manufacturing, the outside diameter. Because the teeth are angled, the physical tip is wider than our pitch circle. Using the formula, diameter plus 2, times the addendum, times the cosine of the pitch angle, we get 43.33 millimeters for the pinion, and 62.22 millimeters for the gear. And look at that, it matches our SOLIDWORKS model perfectly. Math doesn't lie. Now, let's get to the machine shop. Thanks for watching the very first episode of Theory to Reality. If you want to see more engineering deep dives and watch us prove the boss wrong, make sure to hit that subscribe button. See you in the next one.